If you were faced with trying to integrate this function right here, you might try doing du over u, but it wouldn't work because du has to be 4x minus 7, and we won't get 4x minus 7 if we multiply the top by 4. If you look up here, what we're going to learn to do is use integration by using partial fractions. When we have a polynomial over a polynomial, and if the degree of the numerator is smaller than the degree of the denominator, and if we can factor the denominator into distinct linear factors, then we can use partial fractions. So we first factor the denominator into 2x minus 1 times x minus 3, x minus 13 on top, and we now have an integral in which we have what we want. And so next, we look at how we can show that this fraction is the result of adding two fractions together. If we were to add these two fractions together, we'd have to get a common denominator, which would be 2x minus 1 times x minus 3, which we see here. So we're going to say we have something over 2x minus 1 plus something else over x minus 3 is going to add up to be this. In order for that to be true, that means that a over 2x minus 1 plus b over x minus 3 has to add up to x minus 13 over 2x minus 1 times x minus 3. So the next thing I'm going to do is I'm going to multiply both sides by 2x minus 1 times x minus 3 on both sides, and that will then give me a times x minus 3 plus b times 2x minus 1, which will equal x minus 13. Now I'm going to let x equal 1/2. Why? Because if I let x equal 1/2, that will get rid of the b, and I'll be able to solve for a. So I let x equal 1/2, plug in 1/2 for all the x's. That'll put 0 in this next as a coefficient for b, and I'll have negative 5/2 a equal negative 25/2. And when I solve, a will equal 5, as you can see. Next I'm going to let x equal 3, which will eliminate the a, and then I can solve for b. And if I do that, I'll get 0 equals 5b equals negative 10, and b will be negative 2. If I replace a and b into the integral up here, my a and b values, I get 5 over 2x minus 1 and a negative 2 over x minus 3 dx. Now, we can separate this into two integrals, in which then I'll take out the constant 5 out front and have 5 times the integral of 1 over 2x minus 1 dx, minus, take out 2, minus 2 integral of 1 over x minus 3 dx. Now, it's very simple. I can simply make this right here a u over u. The u is 2x minus 1, and the du will be 2 dx. So all I have to do is put in a 2 times 2 there, and times 1/2 out front, and now I have a du over u. And so over here it's already done. The u is x minus 3, the du will just be dx. And so now I can go ahead and finish the problem, and this will be 5/2 times the ln of the absolute value of 2x minus 1 minus 2 times the ln of x minus 3 plus c. And we've now finished it, and partial fractions helped us to turn it into a simple problem.